Let's just go to the chapter 3. So that is the functions of 2 and 3 variables. So let's just look at the first order of the partial derivative and its notation. So we look at the functions of 2 variables first. If you are given the z equal to the function f x y, so what happens if we say that we want you to differentiate with respect to x? So if you want to differentiate the function with respect to x, it means that you're going to treat the y as constant. So the notation to write the differentiation is just very simple. You just put a small x next to the function, just like this. The small x next to the function f with the bracket xy, or you just read out the bracket, just write a small x next to the function f. Or you also can write del function over del x. Or instead of using the function f, you can use the z. Okay, so you can write del z, del x, or you can directly write zx. They are all refer to the same thing. So let's just look at differentiate with respect to y. If we say differentiate with respect to y, means that you're going to treat the x as constant. The notation to write is actually the same. So what you have to do is just write a small y next to the function. Okay, or you just write without the bracket xy, you just write fy. Or you can use del function del y. Or instead of using function f, you can use the z. So you can write del z, del y, okay, or you can write zy. But please take note that the del here, the del x is actually different with d dx. The del is actually meant for partial derivative. It means that your function has 2 variables, 3 variables, or 4 variables and above, you're going to use del. You're going to use this symbol. So it means that you have more than 1 variable. You have 2 variables, 3 variables, 4 variables, and so on. You're going to use the del x. But if you only have 1 variable in that equation, just x, so you're going to use dx. Now, if you have the notation for the function of 3 variables, that is a function that contain variable x, y, z. So if you differentiate with respect to x, the way to write is actually simple. Just write a small x next to the function f, or you just without the bracket of x, y, z, just write fx, or you have the del, okay, del the function, del x, or instead of the function f, you can write the p, okay, because the p is actually equal to the function f, okay, so you just directly write del p, del x, or you just write px, the small x next to the p. And if we say differentiate with respect to x, you're going to treat the other two the other 2 variables as constant. So that is your y and z as constant. So same thing happens when we say differentiate with respect to y. So you put a small y to your function, okay, or you have you can use the del, okay, so del the function, del y, or you have del p, del y, or you have small y next to the p. Just remember, if you differentiate with respect to the y, so you can treat the x and z as constant. So same thing happen for the remaining variable, that is a z. Just put a small z next to the function, or you can use this notation del, okay. And if you differentiate with respect to the z, so you're going to treat the x and y as constant. Let's just look at the example 1. So we have an example that has 2 variables. So this example, you have the variable x, we have the variable y, and they ask you to find fx01 and fy12. Before we go to solve this example, let's just go back to the basics. So the basic here, we have 3x squared plus 5. So they want you to differentiate with respect to x. Okay, so this is an equation with 1 variable only because you only see x. So let's just differentiate it. If you differentiate it, 3x squared, you differentiate, basically give you 6x. For 5, if you differentiate, you will have 0. So that's why the answer is 6x. So now let's just go back to the example. So we're going to find fx. Okay, so fx means that you're going to differentiate with respect to x, and you're going to treat the y as constant. Now we are doing with the equation that has two variables, the variable x and variable y. So we are calling them as partial derivative. So now when we want to differentiate them, so the notation is actually very direct, so you just have to write a small x next to this function. Okay, and then we're going to look at the item one by one. So let's just look at the first item. Every time you do the differentiation, you just have to keep on asking yourself, do we have the x? Do we have the things that we want to differentiate? So let's just look at the first item, x cubed. Yes, we have the x cubed. So if you differentiate x cubed, basically give you 3x squared. The second item that we have is x squared y cubed. So do we have the x here? Yes, we have the x here. So what happens if we differentiate the x? So if you differentiate with the x, you have 2x. Okay, so you differentiate the x squared, so you have 2x. And how about the y? The y cubed here is actually constant. So this one is 2x. You multiply with the constant y cubed. So it will give you 2x y cubed. And how about here? So again, we're going to ask the same question again. Do we have the x? No, for this item, we do not have x. If we do not have x, it means that the whole thing is actually a constant. So if this is a constant, if you differentiate constant, it's basically give you 0. That's why this is the answer. So now you're going to substitute the 0, 1 into this equation. So it means that you're going to treat the x as 0, the y as 1. So you do the substitution here, and we have the answer that is 0. Now for the next question, they ask you to differentiate with respect to y first, because they say fy12, right? So we're going to settle with the differentiation first. We differentiate with respect to y. So you treat the x as constant now. So all the x that you see here, they are all constant. So we want to differentiate with respect to y. The notation is just a small y next to the function. And again, we repeat the same process. Now we change our question a bit different. So now we're going to ask, okay, we're going to ask, do we have y? So we look at here, we are doing with differentiation with respect to y. So you're going to ask yourself, do we have y? So at here, the first item, do we have y? Of course, we do not have y. So if we do not have y, it means that this item is actually a constant. So what happened to a constant if you differentiate? You will have a 0. How about the second item? The second item, again, we ask again. So do we have y? Yes, we have y. And how about here? The x squared is actually a constant. And y cubed, that is the one we're going to do the differentiation. Y cubed, if you differentiate it, y cubed is actually give you 3y squared. 3y squared multiplied with the constant x squared is actually give you 3x squared y squared. And then for the third item, we ask the same question again. Do we have y? Yes, we have the y. So how about minus 5? Minus 5 is actually a constant. So if you differentiate the y, you will have 1. So 1 multiplied with minus 5 is actually minus 5. So you have the answer here. And then they ask for fy12. It means that you do the substitution. You sub the x as 1, y as 2 into the equation that you obtain. You have the answer that is 7. Let's just look at the example 2. So for example 2, we have 3 variables here. We have variable x, variable y, variable z. So they ask you to find the partial derivative for all these variables. So let's just begin with the del p del x. It means that you could differentiate with respect to x. So you're going to treat the y and z as constant. So let's just look at the item one by one. Okay, so for the first item, so we ask the same questions. So the question is, do we have x here? Yes, we have x. So we have x cubed. So what happens if we differentiate x cubed? So you have 3x squared. So 3x squared multiplied with 5 is basically give you 15x squared. So for the second item, do we have x here? Yes, we have the x. So how about the 4 and y? 4 is actually a constant. Y is also a constant. We just focus on the x, okay? So x squared, if you differentiate x squared, you have 2x, and you need to multiply 2x with the other two constant. 2x multiplied with 4y. So it's basically give you 8xy. So the third item, we do not have x for the third item. So this actually basically a constant. So if you differentiate constant, it's basically give you 0. So we don't write the 0. Just leave it blank, okay? So for the fourth item, we also do not have x here. So if you do not have x here, it's basically a constant. If you differentiate constant, you have 0. Same thing for the last item. So last item, if you differentiate it, you basically a 0 because this is a constant. We do not have x. It means that you have constant. Now go for the del p del y. For the del p del y, so you're going to focus on y. So you're going to treat the x and z as constant. So let's go back to this equation. So now we differentiate with respect to y. You're going to focus on y. So the first item. So we ask yourself, do we have the y here? So for the first item, we do not have the y. It means that this is actually a constant. You differentiate a constant, you have 0. How about here? Do we have the y? Yes, we have one y here. We have y here. How about the 4x squared? The 4x squared is actually constant. The 4 is constant, x squared is constant. Okay, so if you differentiate the y, so you have 1. So 1 multiplied with the constant 4x squared is basically give you 4x squared. Now, the next, so we have the y here. So if you differentiate the y here, so you have negative 3y squared. So we have negative 3y squared. Now, the fourth item, so do we have the y? Yes, we have y here. And how about the z squared? The z squared is actually a constant. So you just need to differentiate y. So if you differentiate y, you have 1. So 1 multiplied with the constant z squared, you have z squared. Do we have the y here? We do not have the y here. So it means that this is actually a constant. If you differentiate constant, you have 0. Because it is del p del y. So for del p del z, so we're going to repeat the same process. You're going to focus on the z. You're going to focus on the z, and the rest will be the constant. So first item, do we have the z? No, we do not have the z, so basically this is a constant. So if differentiate constant, you have 0. How about here? Do we have the z? No, we do not have the z. So it means that this is a constant, so the result is 0. Here, we also do not have the z. So it means that this is also a constant. The constant, if you differentiate constant, you have 0. So how about here? Yes, we have the z. We have the z squared. And how about the y? The y is actually a constant. So if you differentiate the z squared, you have 2z. So 2z multiplied with the constant y, so give you 2yz. And the last item, so we have z cubed. So if you differentiate z cubed, it's basically give you 3z squared. Now we go for the example 3. So this example 3, we have two variables. So you see variable x and variable y only. So let's just find zx and zy. Okay, before we go to solve this example, let's just go back to the basic of exponential. So if you have the exponential of e to the power of 5x, if you differentiate with respect to x, That is very simple. You just have to differentiate on the power. So it's actually 5x. You differentiate it, you will have 5. So 5, put that in front. Okay, and copy back the exponent. So you will have 5e power of 5x. And what happens if we have a constant in front of it? Okay, so we're going to do the same thing. So we're going to differentiate on the power only. So you have 5x, you differentiate 5x, you have 5. So put the 5 in front. So copy back whatever that you have, include the constant and the exponent. So you simplify it, 5 multiplied with 8, you have 40. 40 e 5x. Okay, so we're going to use the same concept in order to solve this example. So in this example, so we look for the zx. Okay, zx, it means that you're going to differentiate with respect to x. You're going to treat the y as constant. First, we'll give you this one. You have the x here, so you have the 5e by x. Okay, so for the second item, we do not have x. If we do not have x, it means that it's actually a constant. So differentiate constant, you have 0. So tangent x. Yes, we have x here. So if you differentiate the x, tangent will give you secant squared. For the ln y, it's actually not an x. It's not an x, means that you will have a constant. So you differentiate constant, you have 0. Now for this one, okay, so you have the x only at the part of exponent. The sine y is actually a constant. This is constant. You just focus on the part that you have x. So if you differentiate this one, e to x, it will actually give you 2e to x. 2e to x multiply with the constant sine y. So it give you 2e to x sine y. Now we go for zy. So zy means that you will differentiate with respect to y. So you just focus on y. You're going to treat the x as constant. So let's just go to the equation, the original equation one by one. So this one, okay, so do we have the y here? We do not have the y, so basically this is a constant. So constant, differentiate constant, you have 0. So how about here? Yes, we have the y. So what happens if we differentiate this? If we differentiate this, we will have 2e to y. Yes, we have 2e to y. How about the tangent x here? Tangent x, we do not have y here. So if you do not have y here, this is actually a constant. So you differentiate constant, you have 0. So yes, we have a y here. So you differentiate ln y will give you 1 over y. Okay, how about here? So you have the y here. You could focus on y, right? Okay, so sine y, you're going to differentiate on this. But how about this exponent? So exponent is actually a constant. So this one is sine y. So if you differentiate sine y, you will have cos y. The cos y need to multiply with its constant. The constant is exponent. Okay, so you will have e to x cos y. Let's just look at example 4. Okay, but before we go to solve this example 4, we go back to the basic first. So the basics that involve with chain rule. Okay, so when you have an equation, the equation contain of one variable and you want to differentiate with respect to the x. Okay, so we're going to apply the chain rule here. So what you have to do is, okay, we're going to look at layer by layer. We treat the bracket as one layer and whatever inside the bracket as another layer. The first thing you have to do is you just do the differentiation with the bracket. So just look at here, we have bracket power of 3. So drag this one, the 3 to in front. So you have 3 a bracket, and then the 3 here you have to minus with 1, so you have 2. So this is we are only dealing with the differentiation with the bracket, so that's why you have a 3 bracket squared, and then whatever inside the bracket just copy back. So that is the outer layer. Okay, so now we're going to deal with whatever inside the bracket. So this is the inner layer. So we're going to differentiate with the inner layer, that is the equation inside the bracket. So if you differentiate this one, so you basically give you 8x. 8x. Okay, for 7, if you differentiate, you have 0. So we simplify it, we have 24x with the bracket square. Okay, so this is basically we differentiate with respect to x by using the chain rule. Now we can apply the same concept to this example, and this example involves two variables, variable x and variable y, and we'll do the partial derivative. Okay, so go for the first, that is zx. So zx means that you're going to differentiate with respect to x, you treat the y as constant. Okay, so the way to do is actually very simple. Just have to drag the 1 over 2 to in front, and the bracket you have to minus 1. So you have 1 over 2 in front, and this power here, so you have the minus 1. So 1 over 2 minus 1 is give you minus 1 over 2. So whatever inside the bracket, you have to copy back. Okay, so after we have settled with the bracket, we go to the equation inside the bracket. So equation inside the bracket, you have 4x squared minus y squared. So remember, we are dealing with x. We are differentiate with respect to x, means that we're going to focus on the x only. For the y, it's actually a constant. So if you differentiate with respect to the x here, so this is basically give you 8x. So we have 8x here. This is actually a constant. So if you differentiate constant, you have 0. So we have this line. So then let's simplify it. So 1 over 2 multiplied with 8x is actually give you 4x. Okay, and you see that I have minus 1 over 2 here. You can drag it down. So it become a fractions. Okay, just write it become, okay, this is become the part. This is become the denominator. Okay, so then we go for the zy. For the zy, repeat the same process. Okay, so I want you to try on this one by yourself. Okay, pause the video for a while and try to look for the zy by using the same concept. Now for the zy, so we repeat the same process. Okay, so drag the 1 over 2 to in front. So you have 1 over 2 at front. Okay, the bracket you have to minus 1. So if minus 1 is basically give you minus 1 over 2. Okay, and then whatever inside the bracket, just rewrite it back. Okay, so we have done with the bracket. Go for the equation inside the bracket. So now equation inside the bracket is 4x squared minus y squared. So we are focused on the y only because we are doing with the differentiation with respect to y. So it means that you're going to focus on y only. So the x is actually a constant. So if you differentiate constant, it's actually give you a 0. How about this one? You differentiate respect to y here, so you give you minus 2y. So we have to minus 2y. Now simplify it. So 1 over 2 multiplied with negative 2y, will give you negative y. And you have negative 1 over 2 here. So the negative 1 over 2 here, this bracket is become your denominator. So we have the fraction as this one. So this is the answer for the example 4. Now try to do this discussion question.